Chunks like "it grew 12% are impossible to retrieve without the missing subject. Anthropic's contextual retrieval prompt prepends that identity before indexing so the right passage can surface. You'll prepend document context to each chunk before indexing so previously ambiguous passages surface for the right query. I'm Professor Pi, teaching search and IR with simple Python. Many search pipelines split long documents into small chunks to keep indexes fast and embeddings compact. That works until a chunk loses its identifying labels. A line like "it grew 12% becomes meaningless alone. Contextual retrieval for context-poor chunks fixes that by adding a little metadata back into each chunk before you index it, so a later query can match the right passage. At its core, the idea is simple. Take a chunk that looks ambiguous on its own. Generate a short context string that names the missing subject, date, or document ID. Prepend that string to the chunk text and index the combined string. Then, a user query that mentions the subject can actually find the right chunk. Strengths are practical and cheap. You do preprocessing once and store a slightly longer index string. Weaknesses are storage and the need to keep the source document available at preprocessing time. We will build a tiny demo that shows the failure, generates a Claude prompt that extracts a short context label, and then indexes the contextual chunk to rescue retrieval. That demo maps directly to real notes and reports where single lines need a head word to be findable. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We first create the smallest dataset that makes the problem visible, so we can see the failure in one pass. This snippet makes the retrieval failure visible with the smallest possible dataset. The document clearly names ACME Corp and Q2 2023, but the second chunk only says the company's revenue, so the subject and date vanish when we split it out. The tiny scores calculation is just term overlap, representing the exact match side of retrieval in a compact teaching form. The important move is comparing query against isolated chunks, not the full doc, because that is where many real indexes lose recoverable signals. The output shows the best bare chunk score is 0, which is the failure we need to fix. Now we need a way to recover those missing labels automatically from the original document during indexing. This example turns the failed chunk into a prompt that can recover its missing retrieval labels. The context prompt function wraps the full document and the target chunk in simple tags, then asks for only a short context string. That keeps the model focused on producing metadata like text rather than rewriting the passage or answering a user question. The trade-off is that the whole document must be available during preprocessing, but the output can be stored once with the index chunk. The printed character count confirms the prompt was assembled, which matters before we send it to Claude. With a prompt ready, we call the Anthropic Messages API and capture the compact context Claude returns. This code sends the contextual retrieval prompt to the Anthropic Messages API and stores Claude's short answer in CTX. The client.messages.create call uses max tokens equals 80 because this step should produce a concise retrieval aid, not a summary of the whole document. Temperature equals 0 is used to make the preprocessing behavior steadier across repeated runs, although API responses can still vary slightly. The returned msg.content0.text is the text we will prepend before indexing. The output only checks that usable context came back, which is the minimum confirmation needed before changing the index. Next, we check whether prepending that Claude output actually helps a simple keyword retriever. This snippet compares the same chunk before and after prepending Claude-generated context. Contextual is the exact text you would send into a keyword index, embedding model, or hybrid pipeline, with CTX placed before the original chunk. The scoring is intentionally small. It checks how many query terms are now visible to the retriever. In production, this score would be replaced by BM25, vector similarity, or rank fusion. But the mechanism is the same. The output shows the term gain, making the retrieval improvement concrete before we build the tiny index. Finally, we turn the pre-processing into a minimal pipeline that builds a contextualized index and runs a query against it. This example turns the pre-processing idea into a minimal end-to-end baseline using the Anthropic Messages API. Make context calls client.messages create for each chunk. Then index stores Claude's context directly above the original text. The ranking step is still compact term overlap, but it now operates on the same contextualized strings you would pass to a real search backend. The query asks for ACME Q2 2023 and the previous quarter, so the once ambiguous revenue growth chunk has the missing labels it needs. The output shows the top contextual chunk ID, completing the small retrieval demo. To map this toy demo to a real project, you would run make context once over a full quarterly report corpus, store the contextualized strings in your index, and then run a proper retrieval model over those strings, instead of a toy overlap score. It is a pre-processing trick that attaches short, machine-generated labels to context-poor chunks. Use it when chunking or summarization strips essential identifiers like company name, date, or section. One caveat is storage and pre-processing time, since you must hold the original document during the labeling step and store slightly longer indexed entries. A practical next step is to swap the toy overlap scorer for BM25 on the contextualized strings and tune BM25 K1 and B using a small validation set of representative queries and known good chunks. That change will show you how much real ranking improves once the missing metadata is restored. If short practical IR helps your projects, subscribe and watch the IR videos.